Hello. Thank you very much for coming along. So this is probably the third or fourth event like this that we've done. I think a couple of months ago, or even longer, was the last one we did. But the idea is we are planning to do these sorts of events quite regularly, just to try and spread and inform people in terms of both climate change, but also thinking about responses to and how we can change our own lifestyle. So I'll just introduce myself. I'm Paul Turner. I stand in front of you as a sort of concerned citizen, but also my day job is I'm a geography teacher, so actually this is something that I spend a lot of my time reading up on, teaching students and young people about, and I've sort of gone out of my way to try and incorporate as much of this into the teaching that I do within my own school. So this is just an overview of what I'm hoping to include. We'll try and go speedily through, and I'm keen to include the opportunity for discussion and questions towards the end as well. One of the first things I wanted to start with was to say this is often framed as a debate in the sense that it's still open-ended, but the reality is that about 99% of scientific reports suggest that climate change is human-induced, so that it links climate change with human activity. So there isn't necessarily the debate there. Climate change is happening, and the majority, 99% of scientific evidence conveys that it is linked to human activity. And throughout my presentation, I'm going to use graphs and data from lots of very reputable organisations like the Met Office and NASA, lots of other big scientific organisations. This is actually an activity that I use with students. Ask the question, which of these do you think is the most important climate change number or statistic? And actually, by the time I finish teaching them this topic, I expect them to know exactly what all of these numbers mean. So I would be amazed if anyone in this room knew all of them. Something like 7.3 billion is actually, that's slightly outdated. That number is probably 7.5, 7.7 billion. Any ideas what that is? World population, yeah. There's a whole debate around world population. I don't know if anyone saw Chris Packham's programme recently that was sort of inferring that we should be worried about the number of people. Hopefully, in what I say later on, you'll understand that maybe it's more to do with the lifestyle that people lead and the expectation of their level of consumption that is more important than actually how many people live on Earth. What about 1 trillion tonnes? Any ideas what that is? So that is framed as humanity's carbon budget, and it's the amount of carbon that we can put into the atmosphere and then stay within perceived safe levels. And that perceived safe level is actually, it's the 1.5 degrees Celsius. So in terms of global sea surface temperatures, collectively, this was agreed at the last big climate conference in Paris. So the agreement was that we should try and stay within 1.5 degrees of warming. I'll show you later on, well, actually it's one of the other numbers, how much warming we have seen already. 1 degree. There's some dispute, it could be 1.1, but we've definitely seen at least 1 degree of warming. 100 million barrels, any ideas? Oil, but how frequently? How to? Yeah, per day. So at the moment, the world consumes 100 million barrels of oil per day. What have we got? The parts per million, ppm, that's to do with atmospheric carbon dioxide. So where we're at the moment is 410 parts per million, and again this agreed or perceived safe level is 350 parts per million. So we're trying to get back down to that level, 350. 3.3 millimetres per year, sea level rise. So that's the current rate, but that's actually increasing at an increasing rate. So next year it'll be slightly higher and higher and higher. A lot of this data is can be presented in some really interesting ways. So you might be able to start seeing that a little bit more. This is a spiral graph. and it shows you global temperature change between 1850 and this is 2016. And what you can see there is as it expands out, that's showing that the temperature increase has been getting bigger. So it's increasing at an increasing rate. This is another, I really quite like this representation. This is by someone from the University of Reading called Ed Hawkins, and these are called the warming stripes. And what this does is it uses Met Office data from 1850 to the present day, and each of those bars represents a year, and it shows the variation from a 1990 baseline. And what you can see is that the darker blue are colder years from that baseline, and then the reds are warmer, and then the darkest red. So, over the last 10 years, over the last 7 years, over the last 5 years, we keep breaking records and we have the warmest years. So at the moment we're seeing this increasingly warming trend. This then, slightly more complex, not as clear, this is for England. So from the website's called Show Your Stripes. You can actually, you can look at the globe, or you can pick certain countries and have a look at different spreads of data for different periods of time. But the idea is, it's again, this shows a warming trend. It shows that temperature has been increasing and we're experiencing warmer and warmer years. So we can put that in a much bigger context. So if we go back 400,000 years, we can use something called climate proxies. So there's a whole variety of these. We can look at ice cores, we can look at tree rings, and they give us a pretty accurate representation of past temperature. And what we've got is we've previously experienced going from an interglacial, a warm period, to a colder glacial period. And this has been relatively cyclical, and there's lots of reasons why. And the reasons why, in terms of the natural reasons for this cycle, are really well understood. So it's things like sunspot activity. So every 11 years there's a variation from a peak to a trough in terms of output from the sun. The energy from the sun is not constant, it varies, and we know that varies over 11 years. We've also then got something called Milankovitch cycles. I'm going to apologise and say I am going to bombard you with lots and lots of technical terms, but hopefully you're still following. And if anyone wants to question anything I say, there'll be an opportunity later on. So these Milankovitch cycles, though, are all about the orbit of the Earth, and that varies again. So there's 3 key reasons why, but we then get slightly further away from the sun, and also the angle at which we receive radiation changes. So because of those sorts of reasons, we've had this variation, but what we're experiencing is an unprecedented rate of warming. So the rate at which the temperature has increased that you saw in these sorts of graphs, this sort of pattern has not been seen in human history. And if you're going to find that sort of rate of change in geological timeframes in the history of the Earth, you've got to go back millions of years. So the other thing then that temperature is closely related to, and again the science of that is clearly understood and has been known for decades, is the relationship with carbon dioxide. So this is from it's called the Keeling curve, and it's from an observatory in Hawaii. So in the middle of the Pacific Ocean, there's this observatory that has been recording atmospheric carbon dioxide concentrations since around 1960. And there's an interesting pattern. Annually, there's a peak and a trough. The reason for that is that the majority of the land mass is in the northern hemisphere, and so when it is the northern hemisphere's summer, the trees have lots of leaves and they take in lots of carbon, and then during the winter in the northern hemisphere, those leaves drop and the carbon is released into the atmosphere. So you get this peak and trough over a year, but what you've got is an obvious trend there in terms of increasing concentrations. And you can see 1960 down below 320 parts per million, and we're now up about 413 parts per million. Again, we could put that in a historical or a geological context. This cyclical pattern, going back hundreds of thousands of years, closely correlates with, there's Al Gore, have anyone seen, what was his? The Inconvenient Truth. he makes a big deal of this in terms of relating the two and going up in a cherry picker, and he makes the point of top right is where we are now. You need to go back millions of years to find a time. This is well before humans were on the Earth, to find carbon dioxide concentration the same as it is now. Yeah, so it's never been that high in human history. So this is then just to illustrate the sea level change. So there's a big network of buoys around the world which is constantly collating this sort of data, and you can see there there's a slight upward trend in the sense that it's increasing at an increasing rate, but 3.3 millimeters per year on average. So again, in different regional areas there's more, in some places there's less, but you can start to see that actually that adds up year on year. Thinking then in terms of so we've thought about carbon dioxide, temperature, and sea level change as some of the key sort of variables that we can measure and to understand in terms of climate change. You can then start to think about the impacts that we're seeing. So this is a photograph from Australia from the recent forest fires. So those sorts of events happen annually. So Australia experiences forest fires. They're a natural occurrence, they're a natural event, and that actually they're important for regeneration of forests. It's the same for the UK as well. Forest fires are natural. But what we can say, and there is scientific evidence that now links this, and there are scientific reports that explain this, that because of climate change, we can now say that the frequency of these sorts of events, and also, so the recent flooding that we've experienced in the UK as well, the frequency of those events has become more frequent, so the frequency has increased, but also the intensity of those events. And it's the same then with the forest fires. Think about the spatial spread of them and how fierce they were. That factor has been exacerbated and increased due to climate change that is linked to human activity. And we can now say, there's some really clear reports that say that we can link specific weather events, so sort of these sequences of flooding or forest fires, with climate change. So this was a recent Met Office sort of report that then says, okay, if we compare the climate, which is an average of the weather over a 30-year period, from the 1961 to 1990 average between 2008 and 2017, we can see that we are experiencing in the UK higher maximum temperatures. We've got longer warm spells as well. And this is where that 1 degree Celsius rise in itself doesn't sound like much. It sounds a bit inert. During the day, we might experience, depending on the time of year, you might have about 10 degrees variation between night and day. So 1 degree sounds pretty tame. But what we're saying is, in terms of climatic averages, when you shift the average 1 degree, what you're starting to do is move the events at the extremes. So you push those further up along this spectrum. So higher maximum temperatures. What we've also got then is higher minimum temperatures. Fewer very cold days, so the climate becoming milder. Shorter dry spells though, because if there is more energy in the weather system, what you're doing is essentially supercharging it. So you put more energy in, there's more evaporation and also more precipitation. So the rain that we do experience is over a shorter period of time potentially, but it's more intense. So patterns of rainfall change. And then you can start to think, well, that has an impact on agriculture, on our lives as well in terms of the weather that we experience. This report was a pretty important one that came out last year, so I can't think, it's maybe every sort of 4 years. The IPCC, which is the Intergovernmental Panel on Climate Change, which is a part of the United Nations, but essentially it's a group of international scientists. Now they don't do research themselves, for this, what they do is they collate lots of scientific evidence and put it together into these sorts of reports. And the idea of those reports is to simplify it for governments and policymakers. So the idea is these reports were a sort of summary. So this one that came out last year really emphasised the importance of this 1.5 degrees of warming. Now, if we at the moment are we're at 1 degree Celsius and think about the floods and the fires that we're experiencing, it doesn't take much of a leap to then start thinking about, well, an extra 0.5, what would that be like? And actually, I'll show you in a minute, the trajectory that we're on is not to stay below 1.5 degrees of warming. We're on a trajectory that's potentially much higher than that. The other thing then that this IPCC report emphasised was the urgency of action. And it's a slightly contentious number, 12 years. Now, we have understood the science of this for a very long period of time, and it's the motivation to act that is the thing that's maybe changed, or that particularly in the last year or two has become, there's more of an urgency that's been felt. Obviously, putting a time frame on anything is slightly kind of silly, really, because it's not that we're going to come 12 years and suddenly someone will flick a switch and everything will be different. And that's part of the problem with this as well, though, is that because it's such a gradual change, it's difficult for people to kind of comprehend that and to understand it. So, yeah, 12 years. This is, again, something that I've used with students, and maybe this is something that you wanted to note down, or if you've got a phone, you could access this. I'm going to show some of these questions in a minute and use them as a bit of an end to the science bit. But this is a climate change ignorance test. So there are 20 questions, and the idea is it challenges people as to how much they really know. So this is a selection of some of them, and actually some of them that we've talked about. So climate change has only occurred in the last 140 years. What do people think? It's all about the language, because again, something I've not mentioned is this term global warming. People often interchange the two, climate change, global warming. Now, global warming is a potentially more dated term, and actually what global warming refers to isn't the same as what climate change is. Climate change is a much broader term, and it takes into account changes in rainfall, where areas of the world is potentially getting colder. So global warming is all about the warming that has occurred because of human activity. So if it said global warming has only occurred in the last 140 years, then that's potentially a true statement. But climate change, as I said, is a natural process that's been happening over the whole time that the planet has existed. The climate has constantly fluctuated and changed. Number of deaths per year that the World Health Organization attributes to climate change. Any ideas? Was it 150,000? This is really interesting because online, this survey has been, nearly 2,000 people have had a go at this, and everyone underestimates this figure. So there's another figure later on as well, giving it away a little bit, but yeah, most people don't think it's that high, but it's 150,000. But again, it's a little bit spurious in the sense that it's difficult to actually define this. Someone doesn't die, has an autopsy, and the coroner doesn't say that's because of climate change. These things are much less visible. Number 3 there needs to be changed to 99% really, but 98, 99%. What I would say about that science one is, one of the arguments that's often used, and actually I've heard Damien Hines say this, is that the science or the scientific process is all about questioning and debating, and science in itself is never 100% sure. That's definitely the wrong thing to think, in the sense that yes, there is a scientific process and technique used to sort of come up with an experiment, but once you come up with this sort of, we can think about levels of uncertainty, but what we're saying is the uncertainty associated with this climate science is so small that we essentially are 100% sure. Number of people estimated to die from poor air quality. 40,000, yeah. So that's just in the UK. The majority of that from cars, from the internal combustion engine, but then also lots of it from industrial processes, and in terms of maybe where we get our energy from. Yeah, and then this last one, 100 million barrels of oil. Okay, so we've thought about the science. We're going to now think about moving forwards in terms of what will the future be like, and what can we do in terms of our own behaviours. So the best way to think of this is in terms of the probable future, but also the possible future. So I know when I talk to my students, a lot of them think that they're on a conveyor belt, that their life is sort of defined, panned out. They do certain things along the way, but what they end up doing at the end of it, it's not so much up to their, in their control. And I think a lot of people live their lives in that way, that they think, yeah, you've got to get a house, got to get a car. Obviously you have to own a car. There's no choice. You have to have a car. And what I like to challenge them with is to say, okay, well actually, what if you flip it on its head and think you are in control of what the world is like. The world is made up of human actions and humans, and if you choose to want to live in a different future, that you can make that happen, that it is through humans. Those things change. There's one of my favourite quotes is the idea that never doubt a small group of people to change the world. In fact, it's the only thing that ever has. Think about some of the big events like suffrage, or we think about black rights, or we think about the way that the British population responded to the Second World War. That there's, again, some of this stuff might sound a little bit controversial in a sense, but we need a spirit of change that is associated with those sorts of things. That's the sort of movement that's needed in order to make the world a better place. And the way that I like to think of this is that I want to live in a world that is happier for people, but also healthier for people and the planet, and that there's a link between people and the planet. And again, that comes back to our idea of nature, and do we think of ourselves as part of nature or apart from nature? And maybe the way that we and our psyche has changed is that we have become very detached from nature, and that's part of something we need to think about in our relationship with the future. So, this is another graph. This is from the IPCC, from the UN again. This one is thinking about probable futures. So what is the likely warming that we will see? So according to current policies, and again, will governments stick to those? Will governments change? We are expected to see around 3 degrees of warming, which is potentially twice that of what we think is scientists have agreed as being safe. Potentially it could be lower, it could be nearer 2.6, but we're well away, we're a long distance away from this 1.5. And a lot of this is about the pace of change. And what's happened is, because we've delayed and delayed and delayed, that actually the sort of cliff edge, the drop, the change that will be needed is steeper and steeper and steeper. Because essentially there's a cut-off, and we have to reduce the amount of carbon dioxide in the atmosphere, otherwise the temperatures will continue to warm. And what this does then is show, look, well actually, you can see the steepness of the curve. So the sooner we act, actually, the less of a drastic change it would be, and the longer that we wait, well actually, yes, there's going to be really severe changes that people may well dislike. The other important question is about responsibility. Now, one of the things that happens is often it gets thrown onto individuals, and people talk about, what can you do? And we think about, especially within a school environment, it's often turn off lights, recycle. And in the big picture, those sorts of individual behaviours on their own don't have significant enough impacts. And actually, we're at the point in time where we need to think about the scale of the impact of what we do. And actually, we need to throw it back to governments and large companies, and the responsibility potentially needs to lie with those people rather than back onto individuals. But again though, individuals obviously have an impact on governments and companies, and that's something we can think about. But it would be wrong to think that it's up to us in the sense of our individual everyday behaviours, and that's how it will change. What we need to see is large-scale system change. And a really good example of that, or it's only a really small example, but is plastic carrier bags. In terms of behavioural changes, that has had a significant impact. And there hasn't been a big backlash, and people haven't refused to bring their own bag. People have just changed those behaviours. And it's that sort of change that needs to happen in lots of other areas. So I just wanted to show this one, because again, this is another argument that's been used. This is cumulative CO2 emissions. So this is throughout history, rather than thinking what are we emitting right now. So this is 1750, and at the top there, the text isn't great, but it says the UK. So we started our industrial revolution the first. We were the first country to start burning fossil fuels. We've got the USA closely behind there. Where are we? 1900 now. Okay. Yeah, third is Germany there. Fourth is France. But you can see there the USA getting away. 1930s. What kind of countries do you think we might start to see?
China,
India.
India.
So there's India there that just came. We've got fourth there is, so we've got Russia. We've got China now, 1970s. China, just coming up there, 1980s. So the USA, more than double the second place. 1990s. So this is 2010. This is pretty recent, really. We're not going far back. So this is in terms of the. Let me just pause it there so that we've got that. In terms of all of the carbon that country has ever emitted into the atmosphere, that's the kind of total record. So rather than saying, how much is that country emitting now this year, which potentially isn't the figure that you want to be comparing, is it not more appropriate to think about throughout the history of that country, how much carbon have they put in the atmosphere? So we've got there, the UK is, fifth, in terms of, now obviously, the world is constantly changing, and over the next 10, 15 years, there are a whole other variety of countries. You think about sub-Saharan Africa, or you think about Southeast Asia, that are potentially going to emit a lot more. So that ranking might well change, but we've also got questions like, well, who is China emitting carbon for? For us, for sort of high-income countries, particularly in the West, to be living a lifestyle and consuming. Now, what's happened is we have essentially outsourced that carbon, and because of the way that the carbon is tracked, we've not got a system that sort of works out, that carbon molecule, what's that linked to in terms of the product and who's consumed it. It's diffuse, goes up into the atmosphere, and so what that means is China gets blamed for all of those emissions. Well, actually, the reality is it's so that we can have an iPhone, or we can, consume in the way that we do. So there's a slight sort of trepidation in terms of when you start thinking about who is to blame in terms of the country level, and also to think about the importance of this is to say, look, you need to think about it in terms of the full historical record rather than just what we're emitting now. Because again, one of the responses of the government has been, we're doing so much better now, we've dramatically reduced it. Well, actually, we've almost got this debt that we need to repay as well. So we've got responsibility above and beyond what we're just doing within our own within our own country. Okay. Get back. Okay. This is another one then. This is from Oxfam, and obviously what they are really concerned about is inequality. So this is inequality not of money, but inequality in the sense of carbon. So it is the amount of carbon dioxide emitted by the world's population. And the reality is that the richest 10%, which is everyone that's in this room, it's everyone in the UK, a part of that richest 10% of the global population, we emit nearly 50% of the carbon dioxide. So if you think about then the responsibility, often phrases are, it's a kind of, we're all in it together, we've all got to change our behaviours. The reality is that that's wrong. There's a very small proportion of the world who are the very richest who need to dramatically alter their lifestyles, because at the moment they are consuming far too much carbon in relation to everyone else. And actually the reality is that we're definitely the poorest 50% of the world. They need to emit a little bit more. We need to allow them to emit a little bit more carbon so that we balance things out. So if we think about climate justice, if we think about carbon equality, the reality is our lifestyles need to change really dramatically, and actually people in the poorest parts of the world need to be allowed to emit more. Now, what I'm not saying is we need to go back in time, and we need to in terms of, when I say we need to emit less carbon, it doesn't necessarily mean that our living standards are suddenly going to become much worse. That there are other ways that those sorts of things can change. And as I was saying before as well, we need to use this as an opportunity to also then, tackling climate change is a way to tackle large-scale global inequalities, and it's a way to question and challenge lots of the discrepancies in terms of power relationships as well, that is closely linked and tied to all of this. The other one, and I can see there are some very young, relatively young people in the audience, and this should really be firing up young people, is that the majority of people in this room have actually had a very fortunate life in that they've been able to emit a lot of carbon, and proportionately their children and their grandchildren cannot emit anywhere near as much carbon as them. And if you were to think, well actually that means maybe their lifestyle and the way that they live is going to have to be dramatically different. So there's a great inequality in terms of generations. There is intergenerational inequality, that I will not be able to burn as much carbon as my parents or my grandparents. Okay, so thinking about what we can do, what can we do? This is where hopefully there is a hopeful message in this as well. So one of the things, I've been challenged on the square in Petersfield, people saying, oh, you're sort of scaring children. Well, the way that I see this is we need to empower people, and by providing them with the knowledge and the facts, that it then gives them greater understanding and the ability to then do something about that. So you need to understand the situation before you can respond to it. And actually, if you think about this in the right way, rather than thinking about all the negatives of how either the world's going to flood and be terrible and millions of people are going to die, you can flip that on its head and think about how we can make the world a better place, and we can, remove the internal combustion engine and people get out of cars. Well, actually, it's going to make us all happier, healthier. It's going to have an impact on us individually as well that will be positive. So there's an opportunity for people as well as the planet. So this is Professor Mark Maslin from UCL in London, and he summarises this, I think, the best. Now, he takes into account the idea of actually what is most effective in terms of the scale of impact So being here in this room is one of the best things that we can do. We can engage people in conversation about climate change. We can share the facts and the information. Changing your diet is again another big fundamental one. Changing where you get your energy from. And I know that the school that I work at have done that since September. We've moved to a renewable energy provider. And actually, in terms of the amount of carbon dioxide that you emit into the atmosphere, that can be one of the most fundamental and largest in terms of its impact. So if a household changes to one of these sort of green tariffs. Yes, reduce, reuse and recycle, but recycling is not the be all and end all. It's actually using the things you have for a much longer period of time. It's repairing them. It's making sure that other people then, once you've finished using, may well use it themselves. Walking and cycling more. Using maybe an electric car, but the reality is we cannot just flip all of the cars that we have at the moment to electric cars. The reality is that the rare metals and minerals that go into the batteries and the production of those cars are finite, and that there's not enough of that in order to then produce the number of cars. And again, if we think about the poorest parts, the global south, if we think about them wanting the same quality of life and standard of living as us, there's not enough of those sorts of rare metals and minerals for them to be able to have cars. We need to stop flying, or definitely fly less, and then we can start thinking about how we invest our money, and then divesting, so moving money from investing in fossil fuels. And there's a lot of pressure publicly in terms of companies and banks for this to happen, to protest and to make your voice heard, and then to use your vote, and to use your vote in a way that then sends out a message, which is potentially not what happened recently. So, a couple of other avenues. This is from a lady called Kate Rayworth, and she wrote a book called Donut Economics, and that book is all about people and the planet being part of the economic system. So rather than just thinking about economic growth as a measure of success and thinking about GDP and GDP per capita, and it's something that if you listen to the radio or watch the news is still really commonly talked about, in terms of the way that we measure the success of the government. Are they increasing GDP? But economic growth on a finite planet does not work. So we have to think about the way that we measure success differently. And what we need to do is bring in aspects of human capital and human health. So there are scientific ways to measure happiness and the well-being of populations. Bring that into the way that you measure success of a country. And then also think about the environment, and we can think about environmental limits. So the idea of 350 parts per million as being a perceived safe level of carbon dioxide concentration, that's a limit. We need to get below that. 1.5 degrees Celsius, that's a limit. So the Earth, the planet, has its sort of a carrying capacity or ability to be able to provide, and we need to live within that. This lady, she is the independent candidate for the London mayoral race. She's called Rosalind Redhead, and she, for the last year, has been living a zero carbon lifestyle. So it's called sort of net carbon or net zero carbon lifestyle. What that means is she emits 1 ton of carbon in a year. Now, if you get on a plane, if you buy a car, that blows that carbon budget apart. Yeah. But she has proven that within current systems and the way that society functions, you can live within those within that limit. And she's got a blog that illustrates all of that. And she uses a couple of books actually that are at the back from Mike Berners-Lee. One of them is called How Bad Are Bananas? And it uses really clear science to calculate the amount of carbon associated with different behaviours. Even to the extent of, if you want to send an email, if you do it on a laptop, you're actually using a different amount of carbon to if you do it on your phone. And which one's better? Is it better to do it on your phone or a laptop? Or those sorts of choices. Even things like the number of photos on a web page. So a website, just by accessing a website, you're emitting carbon. There is a server somewhere in the world which is hosting that, and by clicking on the website, you emit carbon. So even those sorts of behaviours are so closely linked to carbon. But she has documented all of this, and you can read all about her lifestyle. The other thing I wanted to bring in was that there are a really wide variety of organisations who are also taking this kind of, how can we respond to human-induced or anthropogenic climate change, and respond in a positive manner. So one of the things we need to think about is the way that we interact with open spaces, public spaces, roads, and this organisation called Playing Out, they've set up a network of groups who close streets for certain periods of the week. And there's a certain day that the street is closed, children play out. Now, the reality is that 3/4 of children spend less time outside than prisoners. So there is a set requirement for the amount of time that a prisoner has to be outside. You know, the reality is that both the area and the time that children spend outside has shrunk. And for whatever reason that might be, that's something that we need to change. And it could be through something like this, through reclaiming the streets, using them for different functions. Why is it that we allow the car to be so dominant in urban areas? You know, wouldn't it be much nicer, wouldn't it be much happier and healthier a place if people could just walk without being worried about the car? And again, I know that I cycle into school and walk into school with a small child, and I know lots of other people are really reluctant to do that because they fear for their safety and the safety of their children. And again, if we were to change the dominance of the car and change the way that we use those sorts of spaces, that would then allow other people to change their behaviours. We could do something like this. We could green open spaces. We can give more we could promote nature, yeah? Give more space to nature. There's a really good, something I didn't include in this, a video called The UK in 100 Seconds. And what that does is it documents the land cover of the UK. And the reality is that about 40% of UK land cover is given over to the rearing of animals. It's fields for animals. And that's really closely linked then to our diets. But people think that's how it's always been, or it's difficult for people to think back and think about what was land cover, you know, how much forests did there used to be. And the reality is that's constantly changed. It's what it is at the moment, but it could be different, and we could give over more space to trees. And I know that's something that's been in the news a lot, is let's plant more trees. Again, that's slightly contentious because it needs to be the right trees. They need to be planted and managed appropriately, so planting trees isn't necessarily the solution. But we could green spaces. Thinking about emissions from the way that we travel. Obviously, the big emitters are flying. So there's talk about potentially there being some sort of progressive tax on flyers. So the idea is people who frequently fly could be charged more. Again, through voting, that's something that we could then make happen. But thinking about how we use our cars, you know, particularly inefficient. The majority, something like 70% of journeys are less than 5 miles. So the majority of vehicles we make in vehicles actually could be made quite easily, either with a bicycle or by walking. And the reality is, your next car is not going to be an electric car. It's going to be an electric cargo bike. Yeah? We're going to give over urban spaces far more to the bicycle. And there are other cities and other countries around the world who are already much further along that path than us. Let's move on. Yeah, here's a really good example. these are Dutch children. They don't long to pass their driving test. Again, this is something I tell my students. Give it a year or two, I can imagine it won't be the thing on their mind. It won't be driving lessons and passing their driving test. That'll be something that'll be in the past. Public transport, bicycles, those sorts of things will give them their freedom, and it is true in other parts of the world. So this is happening. It's not some fantasy. This is something that's happening in other parts of the world. The other thing to notice as well is that none of these children are wearing helmets. None of them are wearing high-vis jackets. And again, that's something that's flipped back on the individual. If the car crashes into you, if you have an accident, it must have been the cyclist. And it may be that sometimes that is true, but it shouldn't be used as arguments to say, look, you have to wear high-vis and you have to wear a helmet, because again, there are other parts of the world where the majority of people cycle in normal clothes without helmets, and the number of accidents is far less than other parts of the world. So again, it goes back to that idea of how we interact with the environment and how we use spaces. This is then about diet. So again, this shouldn't come as a massive, as a shock, obviously. Animals emit more carbon dioxide in terms of the rearing of them. They are more intensive in terms of the space that's needed for them, as well as the water and all these other sorts of inputs. So moving to more of a plant-based diet makes more sense in terms of reducing our carbon emissions. It is, again though, it's more complex. So eating locally grown beef or meat does make sense. Also in terms of the way that land is managed, it might be appropriate that we use animals for those functions, but it's the industrial nature of a lot of the farming in parts of the world, particularly maybe South America, that is having a dramatic impact. And so it's the big industrial farming that we should be trying to move away from and move to a far more local diet. What that might mean is that choice is reduced. But if we go to the supermarket today, it's a very artificial construct. It's not a natural idea that you can go to the supermarket any time of the year and there'd be strawberries. And that's definitely something that we need to move away from. In terms of our energy, this is a really good website. This one's called MyGridGB. There's also an international version, and what it gives, so this was taken maybe yesterday, it gives a live feed of where we are currently getting our energy from. So yesterday, we've had some pretty strong winds recently. There was something like nearly 30% of our electricity coming from wind. We still burn coal to produce our electricity. In this day and age, it doesn't necessarily make sense. We've got the potential for us to produce all the electricity we need from renewable energies. Yes, there are arguments to be had about the idea of baseline, so there's almost like a constant amount of electricity that we need, that we consume, and where does that come from? There's lots of arguments about in terms of nuclear and the relationship of that. But what we definitely need to do with our energy is move away from what we have at the moment, which is a centralised energy system where we have really big power stations in certain parts of the country that then sort of have these cables that are really inefficient and then lose a lot of the electricity as they then transmit it. What we need to do is create a decentralised energy system where communities, and again this is happening in parts of the world, Germany for example is somewhere that's been doing a lot of this, is communities creating the electricity and the energy that they need within their own community. So it might be that any new build would have to be self-sufficient in terms of electricity or energy. It may be that a community groups together and has some sort of cooperative and then produces the energy that they need as a community. Again, for a school, it makes sense for a school to produce all of that itself. So yeah, moving from this centralised system to a decentralised, and then also having kind of a variation or a spread in terms of where we get our energy from. I wanted to end on this in the sense of, hopefully there's a lot to think about, but it might be you go away and there's one thing that you think about changing, or one thing that you focus your energy on, because obviously you can't do all of this at once, and it may be that you've already got one thing that you've started to change, and you can then see how that fits within this. One thing we wanted to do was also then say, so we've organised this as part of the Petersfield branch or group of Extinction Rebellion. I'm sure lots of you have kind of heard of that organisation. Yeah, it has this sort of national presence, and we'll continue to. And then as part of that, we have local events. And in the past, we've organised talks like this. We have we've done a cycle ride, and in the coming month, we've got a climate cafe at Winton House on Saturday the 14th, which will be another opportunity for people to talk about climate change and to ask questions. And there'll also be lots of food going on that day. We also meet as a group, and it may be that you think, I might drop in and see what is being discussed and what we're doing within that group. And obviously social media, and it may be that that's how you've heard of this, is then how we communicate a lot of that. So, I'm sure you're sort of overwhelmed, but there is lots of time for questions. Does anyone have any questions about anything? Lucy.
Well, could I ask you to, it's a climate science question, but I wonder if you describe about the